Swayam Prabha. Digital India. Educated India.
Now, it is not that we use only this uniaxial experiment alone to find the metal parameters of a material. There are other experiments and other moduli which are also used. One of the prevalent moduli that is used is what is called as the shear modulus. G, which is defined as the shear stress divided by the angle change caused due to the shear stress. Okay. Now, here what you do is you do a pure shear experiment wherein you take a block and you shear it like this, okay, with the shear stress tau. Okay. Now, what happens is your state of stress is given by 0 if I assume my coordinate system to be x, y and z as my coordinate system. My state of stress for this particular state of stress is 0 tau 0 tau 0 0 0 0 0. Okay. Correspondingly, you will find that the strain from the constellation we want to find what the strain is. You observe that trace of sigma in this case is 0. So, the strain becomes 1 by 2 mu sigma, which is 0 tau 0 tau 0 0 0 0 0. Okay. From the previous lecture on angle changes, you know that the angle change gamma between x and y axis, between the x and y axis is given by 2 times epsilon x y. Okay. So, the angle change in terms of stress would be now tau by mu gamma x comma y, angle change between the x and y axis for this state of shear stress. Okay. Now, so the shear modulus G is nothing but tau divided by gamma between x comma y axis, which is nothing but mu. Okay. From here you get to understand that the Lamé constant mu is nothing but the shear modulus. G. Okay. Now, from the expression for mu that we had before, you can relate the shear modulus to the Young's modulus also through the equation E by 2 into 1 plus nu, okay, from the previous expression that we had for mu, the Lamé constant. Okay.